OAYB is a quadrilateral, and our vectors are already given, directions also given to us. Always check that. If it is not, go by the question one by one, do your arrows and put down your vectors. First, let's express AB in terms of A and B. So vector AB. Vector AB is AO plus vector OB. So you have negative 3A plus 6B. So it's important. Direction is very important. We are going against it, so we need to change direction. So our answer for A is negative 3A plus 6B. You can factor out 3. That's fine. Now, what is important is this. We are going to involve ratio into this now. X is a point on AB. So this is the X such that AX is 1 and XB is 2. So that means that AB is divided into 3 parts, and this is 1/3 and this 2/3. That's the first thing we need to know. Also, we have BY. BY is giving us 5A minus B, which is there already. We're supposed to prove that OX is equal to 2/5 of OY. Right. So now the first thing, as you can see, OY is definitely a straight line. You see it's a straight line. So we're going to still use the same principle. One is a factor, multiple of the other, and share a common point, the same argument. But here we are supposed to prove something here now. So first is to work out what is our OX, what is our OY, and see if we multiply OY by 2/5, we'll get OX. So we start with working our OY. We can start with OX as well, that's fine. So OY. So vector OY is OB plus vector BY. Vector OB is along the direction. Vector BY is also along the direction, so nothing changes. We write what we have and we simplify. So this is what we have for vector OY. Is 5 into bracket A plus B. Now, let's work out OX. OX, we have OX as OA plus AX. And we know AX is a fraction of AB, which is actually 1/3 of AB. So we know our OA as 3A. Let's work out AX separately. We know AX is 1/3 of AB. And from previous working out, we work out AB as negative A plus 6B. So we are going to multiply through by negative 1/3. So multiply through by 1/3. AX becomes negative A plus 2B. Remember, this becomes negative 3A/3 and 6B/3, and that becomes negative 1A plus 2B. So replacing vector AX with negative A plus 2B, this is what I have, and I'm going to simplify that. 3A minus 1A becomes 2A, then plus 2B. Then I factor out 2 to get 2 into bracket A plus B. So I've got my OX vector, and I've got my OY vector. Now what I need to do is that I need to multiply vector OY by 2/5 and see if my answer will confirm the vector OX. So that's what I'm going to do on the next slide. We had OY from the next slide as 5 into bracket A plus B, and we have OX as 2 into bracket A plus B. So if you look carefully, it confirms that one is a multiple of the other. That one is a fact. We can really see that. But to prove, we are going to take OY and multiply it by 2/5. So that's OY. If you multiply by 2/5, the 5 cancels out, and you have 2 into bracket A plus B. But 2 into bracket A plus B is actually what? Vector OX. So that confirms that definitely, yes, vector OX is equal to 2 over 5 OY. And it also confirms that OX is a multiple of what? OY. And it's definitely a straight line as well, and they share a common point X. So that brings us to the end of lesson 4. Watch out for the final lesson 5, where we go into proper problem solving.